So this is 1.6c, continuing on with the lesson 1.6. Yesterday we ended with the difference quotient, or the average rate of change formula, which, if you remember right, looks like this. All over h. Okay, so here's an example. Given the function f of x equals 2x squared minus x minus 3, find the difference quotient. So right here is the difference quotient. So what we're going to do is we're first going to find f of x plus h. So if you remember from yesterday, what we're going to do is we're going to take our x plus h, and whenever we see an x, we're going to put it in its place. So actually what this is going to look like is 2 times x plus h squared minus x plus h minus 3. Okay? And that's going to be all over h eventually, and then we're going to do some other stuff. But right now, let's just leave it as what we're doing is finding this, x plus h. So that whole thing there in red is our f of x plus h. You do the math, and you get 2 times, you FOIL that, x squared plus 2xh plus h squared minus x minus h minus 3. You distribute that 2x squared. I know I'm going kind of fast here, but you guys are quick like chickens, so you should be able to keep up. Okay, so we end up with that big old long Herkin thing. Is there anything that we can combine in that to simplify? Anything there? No, there's not. So that's pretty much as done as we're going to get when it comes to that. Okay, interesting. Okay, so let's go to a new page and see if I can paste that. No, it didn't paste the whole thing, did it? Okay, so that is the first part. That's the f of x plus h. Now we need to continue on and put the f of x on there. So the f of x, if you look at the original problem, was 2x squared minus x minus 3. And that was in parentheses because of that negative sign is going to change the sign of everything in there. So we end up with 2x squared plus 4xh plus 2h squared minus x minus h minus 3 minus 2x squared plus x plus 3 in our numerator. Okay, nothing there that's hard. It's just a lot of stuff, and that is all over h. So then what I'm going to ask you to do is to combine everything, get all your like terms together, and you end up with 4xh plus 2h squared minus h all over h. Okay? So when you combine all those like terms, that is what you end up with. So what are you going to do with this? We're going to look and see if there's anything we can factor. Okay, so out of the numerator, what can I factor out of that?
Minus h.
Okay, let's take just a positive h. I mean, you can take the minus h, but I think we're going to be safer just taking the h, and only because then we don't have to fight with a negative sign there. So 4x plus 2h minus 1 over h, and then that allows us to cancel that h. So Tim, if we would have taken a negative h out, then we would have had a negative sign on the outside of our parenthesis, and then we've got to figure out what to do with that. So that's the only reason I didn't do that. And at this point, there is our rate of change, or our difference quotient, or the slope of that secant line. Okay? So, that is a final example of doing that difference quotient. Okay, the next section that we're going to look at is called composition of functions. Composition of function is, for the most part, taking a function and taking a function of that function. So, for example, if you pay state income tax, which fortunately we don't, but state income tax is based on your federal income tax, which is based on your income. So it's kind of twice removed. So that's basically all a composition of a function is you're just doing function two different times. So for example, you would write it like this. So you would take g of x, and whatever that is, you would take f of that. All right, so you're just basically doing it twice. An example of doing that in real life in your world would be in chemistry. Let's say, for instance, that you are given something as far as the temperature is concerned in Fahrenheit, and you want to change it to degrees Kelvin. Or I guess you don't even say degrees when you say Kelvin. It's just Kelvin. All right, so you're changing it from Fahrenheit to Kelvin. What is Kelvin related to? What other form of temperature measurement or unit of measurement is Kelvin? Are you guys in chemistry? Is Kelvin? Okay. Kelvin is based on Celsius. So we have to go from Fahrenheit to Celsius to Kelvin. So that's a composition. So we change it from Fahrenheit to Celsius, then we take that function and change it to Kelvin. So that's what we're doing in this lesson here, is a composition of functions. That can also be written as, what I have there, f circle g of x. So those two mean the exact same thing. Do you see how that would change if I wrote g circle, f of x? Do you see what would happen to this? It would do the opposite. Maybe not the opposite, but it would be switched around. So, if this is the way I look at it. This here, yeah, that's pretty cool because it spells goth in fog. But for the most part, I like looking at the f of g of x because that makes sense. And you start with the innermost. You start with, on the top one, the g of x, and once you get an answer, you plug that in for the f. Okay, so let's look at a couple. Okay, so we are finding f of g of x. All right, so what do we know about g of x? Well, we know it's this, right? So I can rewrite this entire thing here as f of x squared minus 3x plus 8. Because g of x is x squared minus 3x plus 8. So, do you see what I did there? I just substituted, instead of the g of x, I just substituted what they told me it was equal to. Now remember, from past problems, when we had functions, that means I'm going to look at my original f of x, which is right here, and what am I going to plug in for x? In that 2x minus 5 up there, what am I going to plug in for x? Whatever is in the parentheses there. So, I'm going to write 2 times 2x squared minus 3x plus 8 minus 5. Okay? So all I did was replaced my x with that.
Did you add an extra 2 in the parentheses?
So let's distribute. 2x squared minus 6x plus 16 minus 5, which when I put all my terms together, and we are done. Okay? If we were to switch those around, and instead of doing f of g of x, if we were to do g of f of x, it would be very similar in how it's done. So we would have, instead of g of f of x, we would have g of, what would go in these parentheses, this parenthesis here instead of this?
2x minus 5.
Yes, 2x minus 5. Now we would look up at this one here, and wherever we see an x, we're going to put 2x minus 5. So we'd have 2x minus 5 squared minus 3 times 2x minus 5 plus 8. And then we would just do the math and figure out what that composite would be based on that little bit of a change there. So sometimes you may be given this. That is the same as f of g of 7. Okay, which means we're going to look at my g function, and whenever I see a x squared, I'm going to put a 7 in there. Okay, so the first thing we're going to do is find g of 7. G of 7 equals 7 squared minus 3 times 7 plus 8. Okay, so this equals, when you stick all the numbers in there, that ends up equaling 36, I think. 49 minus 21 plus 8 is 36. So now I have f of, what number goes in these parentheses? 36, because that's what my g of 7 is. So now I go back and I take my, what I have there circled in red, and I put 2 times what? 36 minus 5. Okay, so remember, every time you have an x in an equation, whatever is next to the function goes in place of that x. So you stick that in there and you end up with 67. So if they give you a number instead of an x for your function, you put the number in, spits out a number, then you take that number and put it in the other one. Okay? So you always work from the right to the left. So f of g of x, I'm sorry, you worked from the right. You do this one first, and then you do that one. Okay, given this example, I told you what f of x is, I told you what g of x is, now let's find f of g of x. So, if you know what g of x is, instead of a g of x, we can put f of 5 over x, right? And that equals 1 over 5 over x, because we replaced our x with 5 over x, minus 2. So this is what we end up with as far as our algebraic expression for that. Now the hard part is figuring it out from here. So you do all of your the algebraic wisdom that you've gained over the years, common denominators, and then that equals invert multiply, and you're done. So that ends up being the composition of f of g of x. If I flip them around, then you're going to just do the opposite there. Okay? So that's one that's a little bit trickier just because the algebra is a little bit more complicated. Tim? Okay, so decomposing a function as a composition is going backwards. Okay? So let's say, for instance, that I have the function h of x equals the quantity 2x minus 3 to the 5th power. I want to know what composition I had to have started with in order to get 2x minus 3, that quantity to the 5th power, as the answer. Okay? So before, I would give you f of g of x, and you would get an answer. Now I'm taking the answer, what I have underlined in red there, and saying, how did I get there? What did my f of x have to be, and what did my g of x have to be in order to combine those to get 2x minus 3, the quantity to the 5th power? So does that make sense what we're doing? Just going backwards and find out what we had to start with in order to get h of x. And that's why I wrote h of x equals f of g of x. So let me write that again in my easier way that I like better. Okay. So those are equal to each other. So I have to go backwards. So now what I'm going to do is I'm going to look at my h of x, and I'm going to figure out what I had to do to get there. Well, I had to take a 2x minus 3, and I had to substitute that in for x to the 5th power. Okay, so let me give you the answer so that you can see maybe how we got there. So what I'm saying is that f of x had to equal x to the 5th power, and g of x had to equal what was inside that parenthesis. Okay, in fact, I'm going to put it in parentheses there. All right, so what I did then is f of g of x equals f of, what is g of x? 2x minus 3. Okay? So you see, all I did was substitute g of x. Now what does it say? It says I have to take that and plug it in here, right? So when I plug that in, I get 2x minus 3 to the 5th power. And look what happens. That is exactly what I had there. So when they give you this, the easiest way to do that is to make the f of x, the one furthest to the left, x to whatever power it is, and the g of x, what's in the parentheses. So if you notice here, I made the f of x, the x to the 5th, the g of x, the 2x minus 3. Okay? Does that make any sense at all?
It's getting there.
Okay, getting there, that's good. If it's getting there, that's at least we're moving in that
Just
direction.
have to do it a couple